Good morning, friends. Myself, Professor M. H. Chennaya. In today's video, we are going to learn a problem on the impact strength. And the question for today's video runs like this. A simply supported beam of length 3 meter is struck at its center by a load of 5 kilonewton. The cross section of the beam is given to us. There is a beam which is impacted by a load at its center so that it undergoes bending, and bending strength, in fact bending strength is induced in the member, and we will just see the diagram and note down the values given to us. Friends, we have a beam is of rectangular cross section, they are given the dimension also, and suppose say A and B is the beam. It is simply supported at A and B, and there is a load impacting it at its mid height. This is the load, and this load is 5 kilonewton, and it is impacting at the center of the beam, and the height is to be found out. What is the height of fall given the maximum stress in the member? So it is striking here exactly in the center, and the length of the beam is given to be 3 meter. 3 meter, that is 3000 mm is the length of that beam. And friends, this is the load that is being dropped, and we are to find out what should be the height of the fall so that the maximum stress in the member is not to exceed 100 MPa. First of all, friend, you have to find out what type of stress is induced in the beam. Friends, the beam is simply supported at the ends, and there is impact, and this load is causing a bending stress in the member. And if you refer to machine design data handbook, there is a formula which relates the maximum stress in the member to the stress due to static load and also the height of fall and deflection. And for the case of bending, friends, we have the formula sigma b dash is equal to sigma b multiplied by 1 plus square root of 1 plus 2h by y. Friends, this is the formula that is used to find out the maximum bending stress, where sigma b dash is equal to maximum bending stress. B stands for bending. Maximum bending stress, that is given to be 100 MPa Newton per mm square. Then sigma b is the bending stress due to static load. Stress due to static load. Stress due to static load. Friends, this is given by the formula mv by zb, bending moment divided by section modulus. And these fundamentals every one of you should know thoroughly. What is the bending moment then, friends? Here, this bending moment caused due to this load. How do you find out the bending moment, friends? See here, when this load is kept here for a static case, the reaction at both ends will be 2.5 kilonewton each. So I will say RA is equal to 2.5 kilonewton, and RB is also equal to 2.5 kilonewton. And friends, here exactly at the center, if you take the reaction into that distance, will give you bending moment here, and the valid bending moment will be RA, the reaction, multiplied by that distance here, that is L by 2. L by 2. Friend, RA value is 2.5 kilonewton. 2.5 into 10 to the power of 3 multiplied by L by 2 is 3000 by 2. that is 1500, sorry, 150,500 millimeter. So this will work out to 2.5 into 15 into 10 to the power of 5 Newton millimeter. And there is a general formula WL by 4. If you take also, you get the same answer. That is MB is also equal to WL by 4. Then comes the term ZB. Friends, ZB stands for the section modulus. And for the case of bending, ZB section modulus in bending, and that is given by I by C. What is I? I is the moment of inertia for this section. So this section, the cross section is like this. It is rectangular cross section beam, and we have got the width is equal to 100 and depth of the beam this is equal to 250 mm. This is the cross section of the beam that is made of. Friends, what is I then? In general, for rectangular section, I is equal to BH cube by 12. BH cube by 12. So instead of H we will call D. BD cube by 12. So B is 100. Depth is 250 to the power of 3 divided by 12. You get the answer. And this C is equal to depth by 2. That is 250 by 2. You will get the answer 125. So if you divide I by C, you get the value for section modulus, and hence you will be able to find out what is sigma B with the ratio MB by ZB. And friends, if you simplify, substitute and simplify, you get sigma B equal to 3 that is MB by ZB, and its value works out to 3.599. 3.59. It is stress. So many Newton per mm square. Friends, we have sigma B dash, we have sigma B, and we are left with the calculation of Y, the deflection the member undergoes due to the static load, and we will be able to substitute and get the answer Y. So let's see how to find out Y, the deflection of the beam. So Y is the static deflection of the beam, and that is given by WL cube by 48 EI. These are all fundamental equations, and every one of us should remember them without fail. So friends, Y is the static deflection. We know the load, we know the length of the beam, which is given as 3 meters. E is known to us. I already we have calculated. Friends, we will be able to get this value. So I'll make a substitution. W is 5 into 10 to the power of 3 newtons. That's the load. L is 3000 mm to the power of 3 divided by 48 into E. Young's modulus is given to be 200 GPa. 200 into 10 to the power of 3 MPa. And I we already found out in the previous step. Friends, if you simplify this, you get the deflection of the beam as 0.108 millimeter. So this is the value you have got. Friends, we know all these values, and we should be able to find out what is the value of H. So this is 150 given in the question. Sigma B 3.599 bracket 1 plus square root of 1 plus 2 times h unknown, the value of y we have got it as 0.108, 0.108. Friends, if you simplify this, you will get the height of fall as 39.69, 39.69 millimeter. What's the meaning of this? If you drop this load of 5 kilonewton from a height of 39.69, the maximum stress, bending stress induced to the member will be 100 MPa. And friends, in the same problem, they may even ask you to find out what is the impact factor. So, you know very well, impact factor is the ratio of the maximum stress to the stress due to static load. So, in this case, impact factor IF is equal to sigma B max divided by stress due to static load. Same MB, that is stress means bending stress due to static load. Friends, according to this formula, it is sigma dash B dash divided by sigma. This is given as 150 given in the question, and sigma value you have calculated as 3.599 sigma B, 3.599. So you will be able to find out what is the impact factor IF. Friends, I hope the presentation on this problem on impact strength was interesting. Please go through the complete video, and if you like the video, do share this video with all your friends. Thank you for watching my YouTube video. Have a wonderful day.